Okay. Hello, everyone. Thanks for joining us today. I'm Shelley Peterson. I'm the principal investigator for augmented and mixed reality for Lockheed Martin, and I lead the Optimize team. We build augmented reality capabilities for Lockheed Martin space programs. I'm excited today to have two people from my team join me. It's Dan Anger and Michael Maxwell. We've been very busy this year deploying augmented and mixed reality solutions to programs to run numerous activities. So we're excited to share more with you. Before we get started, I'd like Dan and Michael to introduce themselves. We'll start with Dan.
Hi, my name is Dan Anger. I work on the Optimize team here at Lockheed Martin Space, and I'm a systems engineer working with augmented and mixed reality strategy and development.
Hey everyone, I'm Michael Maxwell. I'm also working on the Optimize team in Lockheed Martin Space as a systems engineer, working with augmented and mixed reality strategy and development.
So over the last couple of years, 3 years, a little over 3 years, we've been deploying solutions out to the programs. We've started with activities that involve drilling, support to drilling activities, torque applications. We use augmented and mixed reality to run position alignment so that we know where to place objects like strain gauges and heaters and thermistors. We have seen quite a bit of success using mixed reality technology. Before we go too far into the details, we'd like to share a video with you.
Orion is the only spacecraft that can take humans into deep space, like the moon and to Mars. We're just finishing that development phase, moving into production, where we'll be launching Orion about once a year. We're using mixed reality technologies to benefit our programs, requirements, and challenges so that we can produce spacecraft at lower costs with higher quality and less time. For Orion, we're using mixed reality to assemble the crew seat. When a technician puts on a HoloLens, they instantly see the work instructions instead of having to go through stacks of rectangular data, whether it's paper or another form of a screen. It understands the environment. It's anchored to the structure, and that allows us to place content within the environment. Being able to see the same design together and look through different options allows us to make those decisions more quickly. With every activity, we're seeing significant reductions in touch labor. We see increases in quality. What we found was that we could take an 8-hour activity and reduce it down to 45 minutes. We see a reduction in cost. We haven't had a single error that's been documented, which is really exciting. We're partnering with Scope AR, who's using Azure Mixed Reality services to bring all of this to life. Mixed reality allows us to move more quickly from concept and design, spanning into tests and operations, and possibly even for astronauts in space.
Okay, so that hopefully provides some insight to how the technology is being used within Lockheed Martin Space. One of the things that you may have noticed in that video is the crew seats for Artemis that are being built. Artemis is an Orion spacecraft. Orion is designed for deep space travel. It's the only spacecraft that's designed to take humans into deep space. And one of the missions coming up soon is with Artemis, which will take the first woman and the next man to the moon in a couple of years. We've been going through the design and development phases. We're now transitioning into the production phase, where we'll be deploying an Orion Artemis spacecraft about once a year. So I'd like for Dan to talk to us about this first crew seat activity that he's designed. It was executed out on the shop floor just a couple of months ago.
Yeah, definitely, Shelley. Thank you. It was definitely a fantastic activity to be a part of. It checked several boxes for us with, executing to that level and working on the Orion crew seat there. I say one of the biggest things that I really appreciate there with that specific activity was the overall reaction with the technicians. You put on the headset and it basically, you see their mind open up to all of the new possibilities, and you see them get to visualize things in a whole new way that they're not used to experiencing. And, it was overall a very fantastic activity. Everyone was very pleased with it. And it's just incredible to see how much faster they're able to build things on the shop floor using that increased technological capability instead of using the traditional methods. So overall, I just think it's a fantastic experience to be a part of and watch all of that come together.
It's exciting to see. And Michael, what have you seen in terms of savings? I know that you've run a bunch of activities as well, including an activity with Crew Seat. What types of savings are you seeing there?
Yeah, that's a good question. And I mean, a lot of savings, I guess, in terms of percentages, kind of depends on the activity. I think you mentioned some of them at the beginning, but anywhere from 50 to 90% savings, which is fantastic to see. And
Yeah.
kind of like Dan said, actually watching the technicians, open their mind to basically watch the holographic content be aligned and all of that instruction and everything like that be right in front of them, and just kind of adapt and love it is very, very cool to be a part of and see.
I've heard them reference all different types of things when they put on the device. The one I hear the most often is that they feel like Iron Man, which always tickles me a little bit. What are the features of the mixed reality capabilities that make them feel like Iron Man?
So I would say there's a couple there. Definitely there's a few features within the Microsoft HoloLens platform where they, you can select things with a laser that basically shoots out of your hand. And, you can also see and visualize things that aren't added into the normal world on a normal basis. So when you put it on, you get to see all of the interface there, just like you see in the Iron Man movies. You see all of that holographic content in addition, and that's a lot of the same thing that they'll see there. You see the additional content, you're able to interact with it, select it, walk through a scenario. I mean, it definitely blends the real world with the digital world, and you get a much better interpretation and work instruction out of it. So it definitely, to a lot of people I've seen, just like you mentioned, they feel a lot like Iron Man walking through it. And I think even on that activity, I think one of the technicians said, "Wow, I'm actually working in the future. This is what I joined Lockheed Martin for."
Right. It's pretty exciting. Michael, what do you think?
Something else that I've heard a lot of people comment on is within the Microsoft HoloLens 2 platform, when you look at your wrist and basically a holographic Windows logo pops up on your wrist, and you actually select that by using your other hand, your other finger, and poking on that hologram, and that actually pulls up a menu. And so that's something else where you're touching your wrist, and yet it's making things happen, which is it's pretty cool.
Amazing. Now, walk me through the process when you start an activity. Do the technicians have prior experience with the HoloLens, or is it typically going out there to run an activity and it's the first time that they're experiencing the device?
So I would say, yeah, a vast majority of our activities, they're pretty much unfamiliar with the platform in general and the software that we're using. So it's, sometimes we get a little bit of nervousness ahead of time because we're coming out with something that they haven't seen before. But that's another part of the deployments that we've done that I really enjoy is watching them come to a new technology right off the bat and using it, how intuitive it is, and how they're able to pick it up and use it right off the bat. So they're basically brand new to it right off the bat, and they can pick it up and use it in a very meaningful way quickly.
Definitely. And just to add on to that a little bit, I mean, it is extremely intuitive. I mean, when you imagine, being able, whether you're trying to type something in on a keyboard, you've got a holographic keyboard in front of you, and you're literally poking through those letters and those characters to select things as if you're actually typing on a keyboard, as well as, selecting other things within the interface or, really everything else. It's very intuitive, just, using your hands, and something that, people tend to adapt to very, very quickly.
Excellent. Well, let's pull up a few pictures to take a look at from recent activities. And while we're doing that, it's really interesting to see the process when you take a device out on the shop floor. The technicians have never tried it on before. They put it on. About how long is it from the time they first put it on to when they start doing the work?
Oh man, yeah, it's actually quite quick. I would say, a lot of times we'll have a little bit of user coordination, just where we spend a few minutes teaching them about the laser that comes out of their hand and how to gesture. But I mean, they basically put it on within a few minutes. They're right off to the start, just working and performing their actual work. So I mean, the actual integration to using it is very, very quick. It's intuitive. It's fast. So yeah, it's only a few minutes in most cases.
It's powerful when it's that intuitive.
Yeah.
Now, This picture is down at Michoud with a fantastic team of technicians that are building the crew seat. Dan went down recently with a scenario that he had built for the full assembly of the crew seats. And Michael went down a month or two later to build the second crew seat. Dan, can you walk through what they're seeing here in this picture?
Definitely. So right now you're seeing the real world parts on the shop floor overlaid with the holographic content. And one of the first things that you'll notice is it looks very similar to a real world photograph, but there's actually a lot of holographic content there. So you'll actually see the seat back there that's on the 4 posts sticking up those mounts. That's actually a real world component, and it's immediately evident that all of the holograms are very well overlaid and that you're seeing direct hologram that means something to the technician. They're actually able to show exactly where those parts are going to go. So they're basically putting it onto this work stand and they're starting to perform their work and assemble this thing up into a completed crew seat. So it's very useful for them to be able to take the parts, and you'll see that on the left, the part sitting on the bench to the left side of that crew seat. That's actually a component that they're going to install where the hologram actually is. So you can see how much it means to them, where instead of trying to reference part numbers or assembly numbers and pull that from a sheet or a computer somewhere, they can actually visually see those parts flying into place to put them on. So that's kind of the process that they went through, starting with the seat back there and then assembling the components all the way up into the final seat assembly. And they were able to do that using that WorkLink application there. You can see hovering in the top right where you can step through your work instructions and see all of the content that you need.
Excellent. Let's skip to one of the earlier stage steps. Now, talk to us about what we're seeing here.
Yeah, so this one is installing one of the mounts for that seat back. So you can see the seat back is face down on the bench there. You can see the technician working, and he actually has, real world tools there. You can see some wrenches and some ratchets and stuff. And you're actually seeing the holographic representation of the parts that he needs to collect. So you can see the blue labels hovering above the parts that he needs to get. So he's actually gathering the parts there that he needs to perform his task. And this quickly and easily tells him all of the information that he needs to support his task, what the parts look like, where they are, how many there are, what the part numbers are. It removes a lot of interpretation, and it saves them a whole lot of time instead of having to go through a bill of materials or something else that requires some interpretation and remembering parts. I usually see them referencing back several times. So this makes it a lot easier to stage the parts in preparation for the assembly, and it makes it a lot easier, instead of having to reference and remember part numbers, they can literally match it up visually and by the part number right there in front of them.
I would think this also serves as a useful tool. Not only are you gathering the parts, you're laying them out in a geometry that makes sense for the activity that's about to take place.
Yes.
So it's located in strategic locations that makes it just a little bit smoother when you're running through the activity.
Yeah, it helps them manage their workspace a little bit better. Yeah.
Right. So let's step to this. And Michael, can you talk us through this step?
Yeah, so basically this, they're actually torquing the bolts into the seat back basically to install the mount fixture. And what they're actually seeing there is which bolts am I torquing and what torquing value am I needing to reference essentially. And so instead of having to go back and search through the actual, printed out instructions or basically be kind of hopping all over the place, the fact that it's literally right in front of them and they're able to just grab the torque wrench and proceed with torquing the bolts with values and everything is definitely speeds up the process.
Yeah, definitely. And then what about this? We have these windows that provide additional data. Describe the benefit here.
Yeah, so this is actually the WorkLink interface, and that's a movable window. It's a holographic window that they can move around in their workspace. And you'll see in the step there that he's looking at, you can see some take photo buttons and also a data entry field. So that's one thing that's very good to mention is you can actually capture photos with the device and capture the progress of your work and use that as a proof of completion, I would say. To say, okay, this mount is done. Here's the picture of it being installed. Kind of acts as the record of authority there. And then also on the top one, you can actually complete data entry in that interface as well. So if you need to say, I torqued this bolt to this value, or here's an ohm measurement for something, whatever data entry you may need, you can actually enter that data there in a holographic form, and it stores locally to the device or can be uploaded to a local server. it helps a lot there, because you're not, again, you're using the device that's on your head, and you're able to interact with that directly right in your work area without having to have another computer there or switch interfaces, put down your parts and then go type things into a computer that may not be right there by the work area. And as you can see in this work area, there's no computer by him, so he would actually have to go leave that area and go walk to his computer and find out that information or complete those buy-offs, where here he can do all of that directly right above his workstation without having additional hardware or software there.
This is excellent. And I think what I've heard the technicians also say that they love the ability to give a voice command and have this pop up wherever they need it. So, they're working around an environment. They may not be right in front of this screen the whole time. If they're working on the other side of the bench or in another location, they can give a quick voice command and it pops up right in front of them. They don't have to go hunt down the data, which is just a time saver. Keeps you from having to remember data as well. Michael, can you walk us through this one?
Yeah, so basically they're installing the harness mounts into the seat pan. And so, once again, this is actually probably one of the most complicated assemblies, or I guess sub-assemblies of actually putting together the crew seat. And I'll let Dan elaborate a little bit more on this one.
Yeah, so this one definitely, there's a number of scenarios that they have to go through to get this installed correctly. They have to torque bolts, insert pins, and then make sure that everything fits in the right holes and perform a number of fit checks. So again, you can see those blue data boxes there where they're seeing all of the information that they need, which procedure to use, what bolts to install, the torque values, any kind of information they need. You can have that in that WorkLink interface like we were talking about before, or you can also put it as a 3D text anchored in the world there, right on top of those pins that they're working on installing. So you can see the guy, working and installing those things. You'll actually notice that his headset is flipped up, and that's one of the other things that we like to see there too, is, they can get the instruction, and then when they need to, they can also flip up the headset and just basically remove the holographic content. They can perform their work and flip it right back down. So it definitely provides some usability and capability there to work in different modes and have all of the information you need right there at your fingertips without even touching a computer or having anything there. It's right in front of you.
Right. And for the group who's viewing this, of course the text is blurred out a little bit here. We had to do that in order to share the pictures, but when you have the device on, of course you have very clear text references here. Yeah. And then back to the final picture. This is what our crew seat looks like closer to the end of the manufacturing process. When they went through this process, did they use any other resources other than mixed reality content?
No, actually, they used just the mixed reality content. I believe they stayed in that work area the entire time. They never had to reference a drawing or a computer. They basically had all of the information they needed right there in the headset. And it was also, with that in mind, I mean, they saved a lot of time trying to reference that information. And they were able to complete that task in a very fast amount of time. I think everyone that was there that was familiar with the activity was very surprised to see how fast that was done.
Right. Now, in the 3 years that we worked out on the shop floor, we haven't had a single error that's been documented while mixed reality was in use. Why do you think that is?
I can initially speak a little bit to that one. When you talk about error prevention and how easy it is to sometimes mix little things up, for instance, there's oftentimes on assemblies, little mount fixtures or things that will go on the left or right side, for instance, of the seat, and they look very, very, very close to each other, almost identical, except for there's little differences about them, and I think the biggest one of the biggest things that I've seen, honestly, is being able to look at that holographic content and immediately see the differences of the two mounts, for instance, and be able to easily distinguish those and pick those out is something that not only prevents errors, but it also really speeds up the process that you would normally spend trying to figure out which mount is which.
Yeah, it definitely removes a lot of interpretation, makes it much easier to understand, physically seeing the component there, what it looks like, where it should go. I mean, it just removes a lot of interpretation, makes it much easier to just not make normal human mistakes that we all make.
Right. You know, almost every time that we analyze the details of an activity, we're looking at that observation and orientation and trying to make the decision and then the action. We almost always see a reduction in that observe, orient, and decide process of the decision logic. We know why. It's because mixed reality just makes the content so incredibly clear. You don't have to interpret and process that data. It takes the load off of the observe, orient, decide portion, and it allows the technicians to do the work. You know, to take more of the action portion and just stay focused on that side. It's really interesting to see how it influences in that way. What's your thought on where this technology will go in the future? What do you see this being used as? Of course, we've used it for manufacturing. Do you see it growing rapidly? Do you see it expanding into other areas?
Yeah, definitely. I can take that one. Yeah, it's incredible to be a part of this industry right now and using this type of capability and technology. I definitely see it growing. It's growing so fast, it's hard to keep up sometimes. It's fantastic to be a part of, and there's so many use cases that you can use. I mean, like you said, we're using it in manufacturing, but there's a whole world of possibilities and other things that we're also working with and deploying to as well. But that basically speaks to the capability that you can use it for quality inspection, you can use it for supplier inspection, or remote collaboration, anything that you can imagine there. I mean, there's almost the world's the limit with how much you can use this technology. And I think that's kind of reflected with also, when you get someone that's brand new to putting on the headset and you see them processing the information there and starting to understand how much of a discriminator this technology can be, and you see all of the use cases and things running through their mind where they come up with all kinds of different ways where it can be used. I think that pretty much speaks to the capability there and how many different places you can use that technology.
Excellent. It's never a dull day. I'll say that. Michael, what do you think about the future use? Do you think it will expand into other areas?
Oh, absolutely. Yeah. I mean, Dan mentioned a lot of them. I think another one that we've been talked to about before is the design side. Actually, how I think the biggest thing is really taking, once again, the interpretation out of it and being able to, I guess speaking as an engineer, I have a tough enough time with trying to visualize something in my imagination, in my head, that, I can't actually see until it's in some way fabricated, essentially. And so the fact that, this is basically giving people a way to be able to see something before it's fabricated is absolutely incredible.
Excellent. Well, this gives you a little bit of information about, how we're using mixed reality within Lockheed Martin Space. And we'd love to stick around and take a few questions for Q&A. People often tell me that I have the best job in the world, and I have to agree, because I get to work with mixed reality, building spacecraft with colleagues like Dan and Michael. We'd be happy to take questions if you'd like.